Hello, welcome to ASMR Chemistry, and I wanted to go through one of the most commonly asked questions, and that is how to calculate molar mass. So I will go through various examples along with how to do it, but there are two things that you will need to do this along with me, or when you do it on your own. And the first thing is the periodic table. Okay, so make sure you have a periodic table handy. And then, of course, you will need a calculator. Okay, so with those two things, we will get started. Hello, welcome to ASMR Chemistry, and I wanted to go through one of the most commonly asked questions, and that is how to calculate molar mass. So I will go through various examples along with how to do it, but there are two things that you will need to do this along with me, or when you do it on your own. And the first thing is the periodic table. Okay, so make sure you have a periodic table handy, and then, of course, you will need a calculator. So with those two things, we will get started. So we have got our calculator, we've got our periodic table. So let's do it. How to calculate molar mass. So, first off, why do we usually need to know the molar mass? Oftentimes it's for stoichiometry problems. Sometimes you also need it if you are creating a solution. You want to have a certain concentration. And it really comes down to wanting to know how many moles there are and tying it in with something that's measurable, such as grams. So the units are always going to be grams per mole. Now, there is a caveat there. And that is, if you are calculating the atomic mass of an atom, just one atom, or maybe you want to know the molecular mass of just one molecule, you might use atomic mass units. But for 99% of the most common chemistry questions, we want molar mass. So that is where it is grams per mole. That's what that molar is referring to. Okay. So this is tying to the periodic table. So let's look at this for a moment. And let's consider, let's just look at carbon, for example. And we see there are a few numbers here. We have the elemental symbol C. We have the name carbon. We see this number 6 up here, these whole numbers. So those are the atomic numbers. And those are telling us how many protons there are. But these fractional numbers these are referring to the atomic mass. So this is in grams per mole what the atomic mass is of that particular atom. In this case, carbon is 12.011 grams per mole. So this is where we can then either determine what is the atomic mass, or in the case of a molecule, the molecular mass. So it's really nice when it's just an atom. We just take the number straight from the periodic table. Okay. So for one atom, okay, that's all we're doing. We just look at the periodic table. So, molar mass, our example here, was carbon. And we saw that that was 12.011 grams per mole. Okay, now let's say we have a molecule. Here we need to add up all of the atomic masses. So the example I'm going to use here, why don't we expand on carbon? Use a molecule that has carbon in it. So I'm going to choose carbon dioxide. So this is our molecular formula. It's telling us that it has one carbon, and the subscript 2 here means there's 2 oxygens. All of these are bonded together to create one molecule, carbon dioxide. So if we want the molecular mass, the molar mass for this whole molecule, we need to add up that and acknowledge that there is just one carbon. And so that means that it is essentially 1 times 12.011. That's the contribution from the carbon. But because there are 2 oxygens, that means we need to multiply 2 times the atomic mass of oxygen. So we get our periodic table, and here's our oxygen. So we look and see 15.999 grams per mole is the atomic mass for oxygen. So 2 times 15.999. Okay. And then we add those, after we multiply through here, we add it all up together. So why don't we at our calculator. Multiply 2. Okay. So this is 31.9. And we'll need to add that 12, right? From the carbon. Let's see what that is. We get 44. Right. 9 grams per mole. All right. This here. This is the molar mass of carbon dioxide. Okay. Now let's take a look at I want to show another example. And that is for a compound. And we see this the most often in ionic compounds. But my point here is that this is for compounds with parentheses. In the formula. I want to show you how to deal with this. So let's look at an example. Would be calcium nitrate. Calcium nitrate has a formula that looks like this. The reason that we have a parentheses around the nitrate is that nitrate is what we call a polyatomic ion. And the nitrogen and these 3 oxygens are all bonded together. And this nitrate acts as a unit. And it is negatively charged, -1. Meanwhile, calcium is +2 charged. So we need 2 nitrates, that's why that 2 is there, to balance out the charge of the calcium. So that's just the backstory of why we have this formula. But the point is that this parentheses here is telling us that there are 2 of everything inside there. So that means we need to multiply 2 by the 1 nitrogen. So there will be 2 nitrogens overall in this whole unit. And there will be 2 times 3, which is 6 oxygens within this whole unit. Okay, So when we calculate the molar mass of calcium nitrate, it looks like this. We have 1 calcium. So there will be 1 times the atomic mass of calcium. Let's see what that is. So we look at the periodic table, we look everywhere, we see, aha, there's our calcium. The atomic mass of calcium is right here, 40.078 grams per mole. 40.078. Okay. Now, how about that nitrogen? We decided that there are 2 of them. 2 nitrogens. So, we'll multiply 2 times the atomic mass of nitrogen. So we find nitrogen over here. There's our atomic mass, 14.007. 14.007. Okay. And now those oxygens. There are 3 oxygens per nitrate. There are 2 nitrates, so there are 6 oxygens. So there will be 6 times. We just saw this before, but as a reminder, here's our oxygen. So 15.999 grams per mole per oxygen. Alright, now I'm going to multiply this across so we can line this all up and see how it happens. So 1, I can actually do this in my head, what do you know? 1 times 40.078. Okay, there's our calcium contribution. And then let's see what our nitrogen contribution is. Okay, look at our calculator now. We've got 2, okay, 28.014. There's our nitrogen contribution. Okay. And then 16 times 15.999. Okay. So there's our biggest contribution so far. It's from all those oxygens that are in there. 95.994. Okay. So, essentially, what we're doing, we're adding these all up to give our overall molar mass for the entire unit, calcium nitrate. Alright, so I already put in our 95.994. Now we're going to add 28. Plus 40. Okay, so there's our final result. 164, 0.86. All right. So here's our final answer here. I wanted to point something out. It has to do with significant figures here. And notice that each of these has 5 significant figures. All right. Same with these. There are 5 significant figures. But when you add them up, you have a result that is 6 significant figures. So just keep that in mind with addition and subtraction, that you can actually increase or decrease the number of significant figures by virtue of adding them up like this. So just an interesting side note. Significant figures, if you haven't noticed that before. Okay. So these are the 3 main types of problems that you can see with calculating molar mass. Either if you have an element that only has one atom, that's the easiest one, directly from the periodic table. It's a molecule, you add them up. And then if you have a compound with parentheses, just be sure that you take note of the value that's there, your subscript, and that you multiply it through times all of the atoms that are inside there. Okay. Alright, I hope this was helpful. Thank you so much for joining me. Please subscribe, and you can hit the bell, and you will know each time I upload another helpful chemistry video done in the ASMR style. But you can always feel confident that these will always be clear and well taught tutorials. I'm a chemistry professor, and I've been doing this for a very long time with a lot of amazing students who always ask me really good questions. And here on YouTube, I'm also getting a lot of excellent questions, so never hesitate to ask. Please give me your requests, anything you would like to see or hear, be taught, as I really enjoy that. Or just leave a message and say hi. It's always great to hear from you. Alright, well, have a good rest of your day or evening, and I will see you again very soon.